This is part 2 of the Unit 4 test review on proportional reasoning. So we've already done some of these problems in the earlier video, so we're going to go ahead and flip to number 12 and start there. So it says, using the map below, find the actual distance in feet between City Hall and the Stock Exchange if the distance between these two places on the map is 5 inches. All right, so since I'm working with inches, that means I'm going to use the scale right here, inches to feet. And so here it's telling me to find it in feet. So once I know the number of feet, I can leave it. I don't have to convert it to anything. So then I'm going to use inches to feet as my word ratio and set up the boxes to go with that. All right, so if I use the scale that I'm given, I know that there are 2 inches and 5,000 feet. And then if I go back to the problem, it tells me the distance between the two places on the map that I'm trying to find is 5 inches, so that would be on top with inches. And then what I'm looking for, let's just call it y to be different, is the number of feet. All right, so to solve this, I'm going to multiply 5 times 5,000. That's 0, 0, 0, 25. And then divide it by 2. 2 into 25,000. I'll go once. Bring down the 5. 2 will go into 5 twice. Subtract and get 1. Bring down that first 0. 2 will go into 10 5 times. And then I still have 2 zeros to bring down, so 2 will go into 0 0 times. And then I have another 0 to bring down. 2 will go into 0 0 times again, and then I'm done. All right, so that tells me that y is 12,500, and really what I'm saying is that there are 12,500 feet between the Stock Exchange and City Hall, since they were 5 inches on the map. Okay, number 13. A tree casts a shadow that is 24 feet long. At the same time, a 5-foot tall person casts a shadow that's 8 feet long. Use similar figures to determine the height of the tree. Excuse me. All right, so shadows are another kind of classic similar figure problem that we use proportions to solve. If it confuses you to see it drawn like this, you can always redraw it with 2 separate triangles. So I have tree here, it's casting a shadow. The shadow is always on the ground. So the tree, we don't know how tall that is. We'll call that x, but the shadow of the tree is this whole entire distance. And it includes the 8 feet here. So the total shadow is 24. And then if I have my person here, all right, it's casting a shadow of, what's it say, 8 feet. So that's on the bottom. And the person is 5 feet, so that's right here. All right, so then I can see the 2 triangles I'm going to be using. With shadow problems, a lot of times they use the words actual, like the actual height compared to the shadow on the ground. So the first triangle is the actual height of the tree, which I don't know, so that would be x. Oh, sorry, x, not x. And then the shadow of the tree is 24. And then if I go back, the actual person is 5 feet tall. The person's shadow is 8, so that's on bottom with the shadow. And then again, I'm going to multiply this way, 5 times 25, or sorry, 24 times 5. 24 times 5 is 20. 5 times 2 is 10, plus 2 is 12. And I still need to divide by 8. 8 will go into 12 once. When I subtract, I get 4. 8 will go into 40 5 times. So I'm done. Okay, so what does that 15 mean? It means the tree is 15 feet tall. Okay, on 14, I have a flagpole that casts a shadow that is 32 feet long. At the same time, a mailbox that is 3.5 feet tall casts a shadow that is 5 feet long. Use similar figures to determine the height of the flagpole. So there's no picture this time, but I can draw my own. I have a flag. Okay, and then it is casting the shadow that's 32 feet. So that's making this triangle. I don't know how tall my flagpole is, so I can call that x. I have a mailbox. All right, so, okay, that's a mailbox. It is 3.5 feet tall, and the shadow is 5 feet long. All right, so now I'm just going to use these to make my proportions. Again, I can use actual to shadow as my word ratio. Draw my boxes. So the actual height of the flagpole, that's what I'm looking for. The shadow of the flagpole is 32. And then the actual height of the mailbox is 3.5, and the shadow is 5. I'm going to multiply diagonally, so 32 times 3.5. Just be careful with the decimal, not to forget the decimal. 5 times 2 is 10. 5 times 3 is 15, plus 1 is 16. Start with a 0. 3 times 2 is 6, and 3 times 3 is 9. Add these up, and you get 1, 1, 2, 0. But there is one decimal place here, so there needs to be one decimal place here, so 112. And then I still need to divide by 5, so I'm going to divide 5 into 112.0, but I don't really need the 0.0, so I'm going to leave it off. 5 will go into 11 twice. I'm going to subtract 10 and get 1, bring down the 2. 5 will go into 12 2 times. 2 times 5 is 10. When I subtract, I get 2. And now I do need the decimal, so I'm going to add it here and move it up, and then bring down a 0. So 5 will go into 24 times. All right, so that leaves me the number 22.4, which tells me that the flagpole is 22.4 feet tall. All right. On 15, it says, which figure is similar to trapezoid DEFG? So that would be this one right here. There are a couple ways to determine which one of these is similar to this one. So it's only going to be one of these is similar to this. One way is to look at the ratio of the sides. So I could look at the ratios of like the side measurement to the bottom, and then see if all the ratios are the same. I could do like this, 4 to 12. Or I could even do it the other way. I could do bottom to side and divide that like that. This simplifies to 1/3. So I could test the ratio of each of these. That's one way to do it. I could set up a proportion so that I was always looking at the side and bottom of each of these. So I can do it that way. If I say, all right, so is 4 to 12, the side and bottom, if I'm doing side to bottom, and then I want to test it against this one, the side and bottom. Is that the same thing as 6 over 14? Well, remember, if two proportions are, if two ratios make a proportion, then their cross products are equal to each other. So I know that 6 times 12 is 72. So I want to know, does 4 times 14 also equal 72? And I can see that it does not. So these are not going to be equivalent. Okay? Or I could say 6 over 14, that's the ratio. If I simplify it by 2, I get 3 over 7, which is not the same ratio as 1 over 3. So that's another way to decide, well, those can't be the same because they don't have the same ratio. Or unit rate is another way to look at it. All right, so again, if I want to set up and test their cross products, I have side to bottom here. So if I do 4 to 12 for this one, and then I do over here, I do side to bottom is 3 to 9. And then I test their cross products. 3 times 12 is 36, and 4 times 9 is 36. So this time they do have the same cross products. So that tells me that these should be similar because they have the same. Okay, but just for fun, we're going to test the last one. So I have 4 to 12 for this trapezoid, and then I want to do side to bottom for this one, 5 to 10. Right, so if I multiply 5 times 12, that's 60. If I do 4 times 10, that's 40. So these are not equal, so this is not going to be similar to this one over here. Again, I could have done 5 to 10 and done it that way and gotten 1/2, which would be different than 1/3. So that's another way, again, to check that those were not similar. But my final answer is WXYZ is the figure that is similar to trapezoid DEFG. Okay. 16. Name 2 ways to determine whether the figures below are similar. All right, so there are 2 ways, really, if you look at the definition of what it means to be similar, to test similarity. And one of them is for them to have congruent sides, or I'm sorry, congruent angles, right? So I can look for congruent angles, that's one way. Now, if I'm looking for congruent angles, then I have to know the measurements of the angles. So that wouldn't work for this one because it hasn't told me the angles of any of these. But let's just for fun pretend if it said, okay, well, this is a right angle and this is a right angle, those would be congruent. If it said this is a right angle and this is a right angle, that means they're both 90, so those are congruent. And then if I said, all right, this one's 60, and so is this one, and this one's 120, and so is this one, okay, then if I knew all the angles and they were the same, the corresponding angles were the same, then I could say, well, yeah, those are similar because they have congruent angles. I don't always know that. So the other way to test for similarity is to look for proportional sides. All right, so this is what we've done a lot of in this chapter, is look at the sides to test for proportionality. All right, and so I could do, since I have, I know the measurement of the top and the bottom, I could do proportional sides that way, top to bottom. I could say 30 over 20. Is that the same thing as 60 over 40? And then we just said to test for similarity, you could cross multiply and see if those are the same. And so this would be 1200. This would also be 1200. So I could say, yes, they have proportional sides. And that's not the only way to test. I mean, that's not the only proportion. I could flip it over and do bottom to side, but I could also do, don't forget, little to big. So you kind of have to look at all the proportions in case it's a multiple choice question. You may not be the proportion you set up, but there could be still a different proportion that would work. So just kind of look at all your choices. If I did little to big, then the proportion would be 30 to 60 and 20 to 40. But when I cross multiply, I still am, multiplying 30 times 40, that's still 1200, and 20 times 60 is still 1200. Okay, so I get the same answer, I just start it with a different proportion. All right, 17, Paula is 1,125 millimeters tall. How tall is Paula in meters? All right, so if you're converting measurements within the metric system, then you just need to remember all the prefixes. And remember we said King Henry died by drinking chocolate milk is the way to remember that. The by is the basic unit, and it's going to be your meters, grams, and liters. So in this problem, I'm starting with millimeters, that's over here, millimeters, and I want to move to meters, that's over here. So I want to know how many steps it takes to get from millimeters to meters. So that would be 1, 2, 3. So then if I start with the number 1025, I'm going to move my decimal 3 places this direction. So if there's not a decimal, it starts at the back of the whole number. I'm going to move it 3 places. 1, 2, 3. That ends up being between the 2 ones. So I can say that 1,125 millimeters is 1.125 meters. In 18, it says Jenna used the recipe shown below to make punch for a party. If Gina doubled the recipe of punch, how many gallons of fruit punch did she make? All right, so I need to know how many gallons, but I also need to pay attention to what she did to the recipe. So she doubled the recipe, so I need to double all these amounts. So instead of 4 cups, this would be 8 cups, and this would be 8 cups, and 8 times 2 would be 16, and 16 times 2 would be 32. So I find the total number of cups she used. 8 plus 8 is 16, plus 6 is 22, plus 2 is 24. Carry the 2, 2 plus 1 is 3, plus 3 is 64. So I know she used 64 cups to make the punch, but I want to know how many gallons that is. And then I need to change cups to gallons. All right, so that's the proportion I'm going to use, cups to gallons. And I can start with, she has 64 cups, and I don't know how many gallons that is. What I do need to know is how many cups are in 1 gallon. So remember we had land a gallon, or I don't know, gallon man, however you want to think of it. You have 4 quarts, and you have 2 pints. And then in the 2 pints, you have 2 cups. Okay, so you're not going to be able to read this because I ran out of room. So I know 2 cups in each pint. So 2, 4, 6, 8, 10, 12, 14, 16. So that tells me there are 16 cups in 1 gallon. All right, and then I just solve it like normal. So 1 times 64 is 64. And then I divide by 16. So 16, I'll go into 64 4 times. Yeah. And that tells me she used 4 gallons to make the punch. Okay. 19, an Olympic-sized swimming pool is 50 meters long. 1 foot is approximately 0.30 meters. About how many feet long is the pool round to the nearest tenth? So in this problem, I'm converting from a customary system to I'm converting from a metric system to a customary system. So they've given me some information here in order to be able to do that. So I'm going to set up my proportion. I'm going from meters to feet. And I know that 1 foot, so it's feet, so that 1 goes with the foot, is approximately 0.30 meters. That's meters, so it goes with my meters. And then I want to know 50 meters in feet, so 50 goes with meters, so that's on top, and then x is what I'm looking for. Okay, so that tells me 50 times 1 is 50, but then I still have to divide by 0.30. So I could drop the 0 out here and just divide by 0.3. If I don't see that, then I know I can't divide by a decimal, so I have to move it. Remember fox and rabbit, so I have to add a decimal here. I moved it twice here, so I have to move it twice here. So I'm actually going to divide 30 into 5,000. So 30 will go into 50 once. That's 20, and I'm going to bring down the 0. And 30 will go into 200 6 times, and that'll be 180. And then I'm going to subtract and get 20. Bring down that last 0. 30 will go into 200 6 times again, which is 180. I'm rounding to the nearest tenth. So I know if I bring up my decimal and I add another 0, I can see that the 6 keeps repeating. Since I'm rounding to the nearest tenth, I know that this is 666 forever. So I'm going to look at the 6 to the right of the number in the 10th place. And since this 6 is bigger than 5 or bigger, then it rounds this 6 up. So this is 166.7 feet. Okay. All right. And then 20, Raheem buys 3 pounds of bananas. They're approximately 453.6 grams in a pound. How many hectograms of bananas did Raheem buy? All right, so again, I'm going from customary to metric, so I need this information here in order to be able to solve it. I'm using pounds, and I'm using grams. So I'm going to use my proportion to set this up. So there are, in a pound, that would be 1 pound, there are 453.6 grams. And then he buys 3 pounds, so that would be on top with pounds, and then I don't know how many grams that is. So if I multiply across, I get 453.6 times 3. That would be 18, carry your 1, 3 times 3 is 9, plus 1 is 10, carry your 1, 3 times 5 is 15, plus 1 is 16, carry your 1, 3 times 4 is 12, plus 1 is 13. There's 1 decimal here, so I know there needs to be 1 decimal here. If I divide by 1, I'm still going to get the same answer. So this is 1,360.8 grams, but the question is, how many hectograms of bananas did Raheem buy? So I need to change this into hectograms. So if I think about my little saying here, King Henry died by drinking chocolate milk. Okay, I know grams is a basic unit, so I'm starting here, and I need to go to hectograms. So that would be 2 steps this direction. So I'm going to move my decimal 2 steps also to the left. So this becomes 13.608, and now I'm in hectograms. Okay, so in this one, based on the information they gave me, I had to change pounds into grams first, and then I could change it to hectograms because I didn't have the information I needed to go straight from pounds to hectograms. Okay. All right, I think that finishes up the Unit 4 test review. Good luck on your test.